So this is going to be the first problem we're going to do today. It's going to take us 2 days to go through this because I want to look at a lot of these here and get a lot of examples and practice with solving these. And so what we're going to do is we're going to use the least common denominator. And least common denominator and least common multiple are the exact same thing, except for the fact that least common denominator, we're looking at the denominators of the fractions, and least common multiple, we're just looking at numbers or sets of parentheses, our polynomials. And so what the least common denominator's main goal is when we look at something like this here, 5 over 2x equals 3 over 2x, is we're looking for a term or sets of terms that we can multiply each fraction by, each rational expression by, to simplify all the fractions out. So if we look at this here and we look at each of the denominators, what would I need to multiply 3 over 2x by to simplify the denominator out? 2x. So I'm going to have to multiply everything by 2x. Well, 5 over 2x would still be 2x, and we only have one that we need. And the last one, 3 over x plus 1, we would need x plus 1. And so we're going to end up multiplying each one of these by 2x times x plus 1 to get each of the denominators to simplify. So if we look at the first one, x plus 1 and x plus 1 would cancel. Here, 2x and 2x would cancel. And lastly, 2x and 2x would cancel. And that's what we wanted. We wanted all these denominators to simplify out completely. Just throw it at him. Okay, now what we have left in the first spot is 3x times 2x minus 5 times x plus 1 is equal to 3 times x plus 1. So this is what we're left with after we multiply through. And we don't have any fractions anymore, which was the point. And we can multiply each one of these here, so 3x times 2x will give us 6x squared. We can distribute the negative 5, which will give us negative 5x minus 5 is equal to, well, again, here we can distribute the 3. 3 times x is 3x, and 3 times 1 would be plus 3. So we get this here. Now, because we have a quadratic, we need to get everything on the same side of the equal sign. So the first thing we're going to do is what? Well, we can just move the 3x over. It doesn't matter which one we move over first, but we're moving everything over to the side with the x squared term. 3x minus 3x will cancel, and over here we have 6x squared minus 8x minus 5 is equal to, not 0 yet. It's equal to 3. And then we can move the 3 over so that everything is on the same side, so we can subtract 3 from both sides. And the negative 3, or 3 minus 3, would give us 0, which leaves us with 6x squared minus 8x minus 8 is equal to 0. Any questions on how we got to this point here? So we multiplied through, and then we moved everything to the same side of the equal sign. We moved everything over, so we get it equal to 0. And we're doing this because whenever we have a quadratic or an equation of a higher degree greater than 1, we need everything on the same side of the equal sign to be able to solve. Any questions on anything we've done so far? Okay. Now we can either factor or use the quadratic formula at this point to solve this here. What do we want to do? Or which one do we want to use? We can factor it, and if we look at this here for factoring, we have a greatest common factor of 2, because 2 will go into 6, 8, and 8. And if I factor the 2 out, factor 2 out of 6x squared, I'm left with 3x squared, minus 2 factored out of 8x would be 4x, and 2 factored out of 8 is 4. Now we can factor this here, so we'll have 2 sets of parentheses. Now because the 4 is negative, our signs are going to be opposite. One is going to be positive and one is going to be negative. Well, the factors of x squared are going to be x and x, because those are always going to be factors for x squared. That's the only way we can have this set up. Now the factors of 3, well, they're just what? 1 and 3 or 3 and 1. So I'm just going to plug a 3 in. Now that comes down to the factors of 4. What factors of 4 do we want to use? 1 and 4 or 2 and 2? Let's try 2 and 2. Now we can check this to make sure it works. Well, 3x times negative 2 is negative 6x. 2 times x is plus 2x, which gives us a negative 4x. Okay, that's exactly what we wanted. So any questions on any of this here? Okay, well, down here at the bottom, a little further, there we go. We have these 2 sets of parentheses that are multiplied together to equal 0. So it means one of these must be 0. So either 3x plus 2 is equal to 0, or x minus 2 is equal to 0. Now at this point we can solve them here. So if I solve the 3x plus 2 is equal to 0, well, the first thing we can do is subtract 2 from both sides. So those will cancel, giving us 3x is equal to negative 2. And last but not least, we would divide both sides by 3, telling us that x is equal to negative 2/3. And that would be one of our solutions. Every day. Now the other solution is going to be over here. We're going to add 2 to both sides. And when we add 2 to both sides, we get x is equal to 2. So any questions on this here? Now either one of these solutions, one of our restrictions. Oh, did we even find the restrictions? And I'll scroll back down here in a second. We just found the solutions. Okay. The restrictions, because if we look back up at the top, 2x, that would tell me x cannot be 0, and our x plus 1 tells me it's not negative 1, because negative 1 plus 1 would give me 0, which would be a restriction. And 2x is when x is equal to 0. Now what we did here is when we simplified down to this here and solved, we were finding the solutions. And it worked out that these two here, and because our restrictions were just 0 and negative 1, neither of which are these, both of these work. So our solutions would be 2 and negative 2/3. So we get 2 solutions for this here. Any questions on this here? Okay. There's no questions on this here. Let's look at the next one. Now this one here, we can't jump straight into just solving and multiplying just yet. Because when we look at this here, Well, the one that sticks out to me a little bit is our x squared minus 1. Is that factorable? Is x squared minus 1 factorable? Yeah, it's what? It's a difference of perfect squares. And because it is factorable, we do need to factor it. And if I factor x squared minus 1, what do I get? X plus 1 and x minus 1. If there is something that can factor in the denominator, we need to factor it to be able to find out what the least common denominator is. And looking at this here, what would be the least common denominator? Well, we'd have x plus 1 and x minus 1, because I need both of those to cancel out the denominator for 12 over the x plus 1 times x minus 1. Because I need to multiply by both of those for that one to simplify. And it works out that this does have an x plus 1, so it will simplify the x plus 1 in our first term. And we also have to multiply it by the 3. So any questions on any of this here so far? Okay. Now let's see what simplifies. Now in our first term, the x plus 1 and the x plus 1 will cancel. In our middle term, both of them, x plus 1 and x minus 1, both of these will cancel. They'll simplify out in the middle term. Well, since the 3 doesn't have a denominator, nothing's simplifying out. It stays the same. Any questions on how we simplified any of this here so far? Any questions on any of this here? Okay. Now let's see what's left. Now in the first spot we have 4x plus 1 times x minus 1. Because that's all that we have left, and we're multiplying those two together. Now in the second spot, well, we just have 12 because everything simplified. Well, we were multiplying it by and what was on the denominator simplified out completely. Plus, what? 3 times x plus 1 and x minus 1. Well, wait a minute, where did I get x plus 1 and x minus 1? Where did that come from? The denominator of what? This here, right? It came from x squared minus 1. So wait a minute, what is x plus 1 times x minus 1? X squared minus 1, right? Because that's where we got those two factors from. So if I wrote them down and multiplied them, I would get what? X squared minus 1, yes? So, I mean, I could write them both out, or we could do what? So this is multiplied by. That's a little bit easier, isn't it? Since we already know where they come from or what it's going to be, might as well just put that down. Because we could put 3 times x minus 1 times x plus 1, and when we multiply all the way through, we just get back to 3 times x squared minus 1. So if we know that we factored it to get those two, might as well just put them back together. So any questions on any of this here so far? All right, let's start simplifying some things. We have to distribute through, so 4x times x is 4x squared. 4x times negative 1 is negative 4x. X times 1, or 1 times x, is going to be plus x. And 1 times negative 1 is going to be negative 1. Now, we don't do anything to the 12 because there's nothing being multiplied by 12. It's just by itself, so we'll just rewrite it back down. But we will have to distribute the 3. So I have 3 times x squared, which is 3x squared. And 3 times negative 1 will be negative 3. Any questions here? Okay, well, before we start trying to move everything to one side or the other, we might want to combine like terms, yes? Well, 4x squared is by itself. But negative 4x plus x will combine to give us negative 3x minus 1. So all the like terms on the left-hand side are correct.
You know, simplify the left and the right together. Like the sign says apart.
Right, the equal sign does split them apart, so we can't combine on either side of the equal sign without doing inverse operations. Now on the right-hand side, the 3x squared is by itself, but the 12 and negative 3 are like terms. So we can combine those. So 12 minus 3 is going to give us plus 9. So any questions on how we got to this point here? We good up to this point? Okay. So most likely this is going to be a quadratic. Well, if we look at our quadratic terms, our terms to the second power, x squared and x squared, if I moved them from one side to the other, would they cancel out completely? Well, if I subtract 3 from 4, I get 1. If I subtract 4 from 3, I get negative 1, yes? So we'll still have an x squared term. I prefer to keep it positive, a positive term, because it's a little bit easier to work with. So I would move everything from the right to the left, just so it works a little bit easier when we don't have negatives with the x squared. So the first thing we can do is, well, we can move the x squared term. It doesn't matter which term we move first, because I could have subtracted 9 first, or we could have subtracted 3x squared first. Either way, we're going to end up doing it at one point in time. Well, 4x squared minus 3x squared is x squared. Minus 3x minus 1 is equal to 9. Now what can we do? We can subtract 9 from both sides, which gives us x squared minus 3x minus 10. Okay, what can we do next? Factor it. Since 10 is negative, our signs are positive and negative. The factors of x squared are x and x, because that's the only way we can multiply together to get x squared. And what factors of 10 would we use? 2 and 5. Which one would be positive and which one would be negative? Yes. Now we're almost done. We need to find out the values of these x, because again, that's what we're trying to solve for. Now our zero product property states that if two things or two or more things are multiplied together and they equal 0, one of them has to be 0. And we can solve from here. So at this point here, I would subtract 2 from both sides, which would tell me x is equal to negative 2. And here we would subtract 5 from both sides, telling me that x is equal to that ain't right. What should x be? Yes. Because it should be x minus 5 is equal to 0. When we add 5 to both sides, we get x is equal to positive 5. Or either one of these are restrictions. What were our restrictions? So this here was our x minus 1 and x plus 1, and we have x plus 1. So we never really listed them again. Because what value is going to make x minus 1 equal 0? 1. And x plus 1 would be negative 1. So even though we didn't go through and list them at the beginning, x cannot be equal to plus or minus 1. Because those are the two values that are going to make the denominator be 0. So it still works out. We're good. Questions on this here? You good with this here? I mean, it's been nice so far that none of our restrictions have come into play, yes? So it'd be nice if it always works that way, doesn't it? You think it'll work this way on this one? I mean, besides the fact that it says it right there. So it's going to come into play here. So there are some that it will come up, but so far it hasn't. All right, we're going to start this one here in a second. I'll give you a second to write it down. Is there any reason I didn't write the term under 8x squared? Because we have to factor it. X squared minus 9 is factorable, yes? And what does it factor to? X squared minus 9 would be x minus 3 times x plus 3. So we need both of these here because it's going to be good to factor this. Because if you'd have gone through and just multiplied each of these terms by x minus 3, x plus 3, and x squared minus 9, you would have had an extra factor of both x minus 3 and x plus 3, which would have meant if, when we get down to the bottom, I believe, because I did this earlier, we'll get a quadratic. If we'd have added those, we wouldn't have had a degree 2, we would have had a degree 4 that we would have had to work with. So it makes it twice as difficult the more factors that we have. So I know from the middle one, I'm going to need x minus 3 and x plus 3, yes? Because they have both of those. Okay? X minus 3, x plus 3. Okay, I'm not going to do this again. We're going to need, you can leave that there. You don't have to erase that. I'm erasing that so I have room. But what did I forget to do again at the start? Find the restrictions. Because I'm going to go on and start off doing that. I'll put those back in a minute. But when we look at all three of these here, three denominators, so x minus 3, the restriction would be what? 3, because 3 minus 3 is 0. So that'd be one of the restrictions. Well, x minus 3 shows up again, so we're good. X plus 3 would be, and x plus 3 would be negative 3. So our two restrictions are these here. And I'll move them up high. So our restrictions, x cannot be 3 and x cannot be negative 3. So if we get a value of 3 or negative 3, we know it is not a solution because it doesn't work. Okay, now we'll go back to this here. So we have all of these here. Now we can go through and simplify out. Yes? So our x minus 3 and x minus 3 would cancel. Well, both of these would cancel with both of these. And x plus 3 and x plus 3 would simplify. So is there anything left in any of the denominators? Well, no, everything's simplified out, yes? So we're good. So the first one we're left with 6 times x plus 3 is equal to, well, 8x squared, because everything simplified in the denominator and everything simplified with what we were multiplying by. So there's nothing left over. Minus 4x times x minus 3. So this is all we have left. Luckily, it's not too much. We don't have multiple sets of parentheses to multiply. So it's a little bit easier or nicer than the last one. Now we do have to simplify down so that we can help, or it's going to help us solve a little bit. So we'll distribute the 6. Well, 6 times x is 6x plus 6 times 3 is 18 equals 8x squared. Negative 4x times x is negative 4x squared. And negative 4x times negative 3, negative times a negative is a positive. 4 times 3 is 12 and x. Okay, what can we do next? Combine like terms, yes? 6x plus 18. Well, 8x squared minus 4x squared, 8 minus 4 is 4x squared plus 12x. So we've combined all the like terms on the left and right side, yes? Okay, let's get everything onto the side with the x squared term. So what can we move first? Does it matter? No. I'm going to subtract 18 this time. First, 18 minus 18 is going to be 0, so it leaves us with 6x is equal to 4x squared plus 12x minus 18. And then what can we do? Subtract the 6x, which will give us 0 is equal to 4x squared plus 6x minus 18. I've done both of those in one step. Is there anything that says that I couldn't have just done that as well? No, we could have done it in one step. We normally do it in two just so we don't get a lot of things mixed up. But I feel like at this point, y'all are able to keep enough of this separated that you could actually do that in one step. So we could do both of those at the same time and not write it twice. There's nothing wrong with that. But if that's a little much, you don't have to do that. We can do it in two. Because either way, we're going to get to this here. Do we want to factor this, solve it by factoring, or the quadratic formula? We can factor it, can't we? Well, wait a minute. What do we notice? There's something in common with all three terms, isn't there? They share a greatest common factor of 2, yes? So I can divide everything by 2, yes? I can do this with numbers. It's perfectly fine to divide everything by 2 or factor it out. Because on the last one, we factored a 2 out at this point, yes? Did that 2 have any, did it affect our overall answer? Well, no, when we went to the 2 sets of parentheses and started solving, we pretty much threw the 2 out, didn't we? So we could divide everything by 2 and be just fine, or we could factor it out. Either way, it's still going to give us the exact same answer. The only thing we can't do with this is dividing everything by a variable. Because dividing everything by 2, I still have the same variables, yes? If I had x cubed, x squared, and x, each one of those had an x, and I divided it out, we've taken one of the solutions and thrown it out. So we can't divide by variables across the board because that's throwing solutions away. But I can divide by numbers because our scalar, we're just scaling it down. We're just bringing it down. So dividing by numbers is fine. Dividing by variables is a big no-no. We don't do that. Now, we can factor this here. Since 9 is negative, our signs are positive and negative. Factors of x are x and x. Well, factors of 2 are, well, 2 and 1, yes? Where's the 2 going to go? Does it really matter? I'll just put it right here. What about 9? 1 and 9 or 3 and 3? 3 and 3. Let's try it first. 2x times negative 3 would be negative 6x. 3 times x is going to be plus 3x. And negative 6x plus 3x is negative 3x. And that's what we wanted, yes? We need to flip the signs. Now that we flip the signs, the 6 would be positive, and the 3 would be negative, which would give us a positive 3x that we wanted. All right, the home stretch. We have two things that multiply together to equal 0, so either 2x minus 3 is going to equal 0, or x plus 3 is going to equal 0. So for the first one over here, the first thing we would do to solve this is to add 3 to both sides. And when we add 3 to both sides, we get 2x is equal to 3. And at this point here, we can divide both sides by 2, which will tell me x is equal to 3/2. And the one over here, we would subtract 3 from both sides, and that will tell me x is equal to negative 3. So these here are both of our solutions, and we're done. Yes? So what are our solutions for this here? Negative 3 is our restriction, so it cannot be a solution. Because anytime a restriction shows up as one of our solutions, we have to exclude it because it will not work. Yeah, you'd cross it out. It's not going to be one of our solutions because, well, if we plug it in, it would cause the denominator to become 0. It's going to cause one of them. It doesn't matter how many it is. As long as it causes one of them to become 0, it does not work. Any other questions on this here? All right. How many have we done so far? 3. So we've done 3. All right. I'm going to stop here. I think we have enough time. We've got a little over 8 minutes or so left, but I don't want to run short on this here. So we're going to stop